Hey guys, this is 11.1 and 11.3. We're going to go over simplifying radical expressions. So what are the parts of a radical? What does it mean when a number is squared? What does it mean when a number is cubed? What does it mean to take the square root of or take the cubed root of a number or a term with variables or just a variable? We will then go on to adding and subtracting radical expressions and then multiplying and dividing radical expressions. And then it will end with using the quadratic formula. And that will be the end of the class. So today we also go over the distance formula after we've gotten comfortable with simplifying radical expressions. Thank you guys for watching, and I hope you enjoy it. All right, here we go. So what is the definition of a square root? Or what do we mean when we say square root? A square root is the term which is multiplied by itself twice to yield the radicand. Okay, let's jump down here to number 2 before we continue talking about square root versus cube root and talk about what parts of the radical expression, right? So radical expression is everything. This part, and this part. Okay, that's a radical expression. It's all of those. What are the components of a radical expression? Well, you have the radical sign. Good. Then you have the index of the radical. That is the index of the radical, okay? That is what we will call it. And then underneath the radical, it's called the radicand. Similar, but not the same. Hold on. Sorry, I don't want to sneeze. And that would be the radicand. So radical sign, radical expression, radicand underneath it. And then the top is the index. Index, radicand, radical sign. Good. So a square root is when you multiply a number by itself 2 times, right? You multiply it 2 times. It times it, that's 2 times. You multiply a term twice to get the number under the radical sign. Good. Cube root means you multiply a term 3 times to get the number under the radical sign. Good. So a cube root is that oh, sorry. Really messes it up when I don't make it a cubed root. So the cubed root of x to the third is x because the definition of a cube root is what term is multiplied by itself 3 times to get the number under that radical sign, okay? And when I added that 3 at the very end, that's what made it a cube root instead of a square root, okay? A square root, cube means 3 because we multiplied it 3 times, right? So cube root is 3, square root is 2. So you can get the same answer to questions that look different, right? The square root of x squared is x, the cubed root of x cubed is x. They both have the same answer. This one is x because we multiplied a term by itself 2 times to get the number or the variable under the radical sign. Good. Okay, so the index is a number. The radicand can be a term or a number or a variable. This is a number, and it's either 3, 4, 5, 6, 7, right? But what about when there is no index? There's no index here. That one has an index of 3. That one has no index, no index, no index, no index, no index, right? When it doesn't have an index, it's an understood index of 2. Okay, so anytime you see there's no number here, we're saying there's a 2, but the number 2 there is so common that we don't need to include it. Okay, so your regular square root, or your regular radical sign, or your regular radical expression without a number here is a square root. Good. So make sure you understand square roots. We're not going to see a bunch of to the fourth roots, or we will see some cubed roots, but it's mainly square roots. And square roots, you can see what they are because there will be no number here. That's a cubed root. That's a fourth root. Those are all square roots. Got it? All right. Square root is a term multiplied by itself twice. Cubed root is a term multiplied by itself 3 times. So the fourth root, we could infer that the fourth root, so after square and cube, you can also call this the second root or the third root. After that, you just call them by their normal numerical names, the fourth root. So the fourth root is going to be a number by itself 4 times. All right, and that pattern continues. Number 3 says, why does the square root of -36 have no real number solution? A real number solution just means you're not using imaginary numbers, which we will talk about in 11.7. We'll talk about imaginary numbers or complex numbers in 4 lessons from now. Until then, we just say this has no real number solution. You can also just say no solution. And it is because if we think about what the square root means that this has to be multiplied by itself 2 times. And if we think about the rules for multiplying 2 numbers, right? Or A times B to get a negative number, A and B have to be the same term, right? So, or sorry, if we were talking about square root, it's the same, right? X times itself. A times B can be negative, right? Because one of them is negative. But if it's just A times A equals negative C, that is not possible because 2 positives cannot be multiplied together to make a negative, and 2 negatives cannot be multiplied together to make a negative. So there's no way to get a negative number, to get the square root of a negative number without using imaginary numbers. And that's why imaginary numbers were created. So there is no real solution because when you multiply any real number by itself, the result is always positive. Any real number multiplied by itself. And let's just stop and say by real number here, I just mean the numbers that we've seen in this class before, okay? Any real number multiplied by itself will have in a positive number. So -5 times -5 will be positive 25. +5 times +5 will be positive 25, right? So any even root, like the fourth root, that also cannot be negative, right? Because something times something times something times something. If it's an even number of times you're multiplying, you're always going to get a positive number. But, right? But if we're taking the third root, we can have a negative number as a real number solution. This is possible. When you multiply that negative number, -5, so we have -5 times -5 times -5 because it's a cubed root, right? That means it's by itself 3 times, 5 times 5 times 5. Negative times a negative becomes a positive 25, but now we get to multiply it by a negative, and a positive times a negative will give us a negative. So if your index is odd, there will be a real number solution. So this is just The cubed root of negative 125 is negative 5. It's not positive 5 because positive 5 times positive 5 would be 25 times positive 5 would be positive 125. So the cubed root of negative 125 is negative 5. If you're more comfortable doing that in your calculator, that is okay. Negative 5 to the third power is negative 125. Good. The cubed root, where is that button? I guess we just have to use math. The cubed root of negative 125 is negative 5. Good. So, but if we wanted to do the fourth root, for example, of negative 125, we will get a non-real answer because it is an even index. If we did the fifth root of negative 125, do you think it'll be a number or an error? It's going to be a number because it's an odd index. If we just do the square root of negative 125, we're going to get an error because that's an even index. So if the index is even, it's going to be an error for a negative number. If the index is odd, it's going to give you an answer. It's going to give you a real number solution. Number 5, explain the difference between the square root of 100, the square root of negative 100, and the negative square root of 100. So the square root of 100 is just asking us, right, what number times itself equals 100, and that's the number 10. I can write it like this. So if I'm factoring 100, it's the square root of 100. If I factor 100, we can say that's equal to the square root of 10 times 10, which is equal to 10. The square root of 100 is 10 because the square root of 10 times 10 is 10. So the way I think about solving radical expressions is I want to factor this into pairs, right? And if this is a second root or a square root, then I need two of the same term and they come out. Once I have a group of 2, because a group of the number of the index, I take them out. 10 times 10 comes out as 10. Good. That's how you solve them. Or you use your calculator. Now, what about the square root of negative 100? What do you think is going to happen? The square root of negative 100, it's just like 100, but it's negative under the radical. It's going to be an error because it is not true that it's negative 10 times negative 10, right? There are no two whole numbers there's no whole number that you can multiply by itself to get negative 100. So it's a non-real answer. However, this third example was a negative outside the radical. What do you think is going to happen? We've never seen this before. Negative, not alphabet, negative square root 100. We know that the square root of 100 is 10, and there's a negative sign in front. The negative sign was underneath it, but here the negative sign is outside the radical. It's negative 10. Good. Because you take the negative sign separate, right? And then you just say the square root of 100, just like it was up here, is 10 times 10, the square root of 10 times 10. If I have a pair that's the same amount as my index, so 1, 2, there are 2 of them, then they come out. But there was a negative sign in front, so we just carry that negative sign. It was here, now it's here. Good. So the square root of 100 is 10. The square root of negative 100 is a non-real answer, and the negative square root of 100 is negative 10. Got it? All right, so for handy reference, complete the following table, and you are welcome to Google it. 0 times 0 is just going to be 0. 0 times 0 times 0 is 0. 0 times 0 times 0 times 0 is 0. 1 times 1 is 1. 1 times 1 times 1 is 1. 1 times 1 times 1 times 1 is 1. 2 squared just means we're multiplying 2 times 2, right? 2 times 2 is 4. 2 times, and then 2 times 2 is 4 times 2 is 8. And then we just say, what is 8 times 2? It's 16. Okay, so we're just multiplying it by itself again. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Or we can say 2 to the 4th is like that. Okay, or you can say 2 to the 4th. Those are all valid ways to find your answer. Okay, 3 is going to be what? Let's do 2 different colors. 3 is going to be 9. 3 times 3 is 9. 3 times 3 times 3 is 27. And then 27 times 3, right? 3 to the 4th. Or 27 times 3 is 81. All right, I'm going to pause the video while I finish this. All right, so I didn't want to, that would have taken me a long time. Here are the answers. And then I just want to go over to the x squared, x cubed, and x to the 4th, okay? We're going to use the rules for multiplying exponents to do this. So this is x squared, right? If you imagine it is just x times x. X cubed is x times x times x. X to the 4th is just x times x times x times x. Good. And then, so we know that those are the symbols. So the squared symbol is to the 2nd power. Cubed symbol is to the 3rd power. 4th symbol is to the 4th power, right? So we're going to take that x squared and we're going to square it. And remember, when you are taking a power to a power, it's x to the 4th, right? And so x squared to the 3rd power is going to be x to the 6th. X squared to the 4th power is going to be 2 times 4, which is x to the 8th. Okay. X cubed squared is x to the 6th. X cubed is x to the 3 times 3, which is x to the 9th. And then x to the 4th is x to the 3rd times 4 is x to the 12th. Good. And then x to the 4th squared is x to the 8th. X to the 4th cubed is x to the 12th. And then x to the 4th is x to the 16th. Okay, so that was just the rule for exponents. Don't worry if that did not come easily to you. I wouldn't over focus on it. Just we filled out this chart so that we could look back on it later. Okay, so let's find the square root. The square root of 121. If you want to look at your chart and see if you see 121. Oh, sorry, it's the square root. So only look in this 121. Oh, it doesn't go, it only went to 100. So what you're welcome to do is just throw it in your calculator. Your calculator should have a button that looks like this, okay? Mine's blue, so that means I have to push the blue button to see it. And then 121. So you just find out, does it have a perfect, is it a perfect, we would call it a perfect square. If it's in this column squared, it's a perfect square. So 4 is a perfect square because it's 2 times 2. 64 is a perfect square because it's 8 times 8. So the square root of 121 is 11. Let me show you also. I guess I have to. All right. Yikes. All right, sorry. If you do not have a calculator, you're welcome to use Desmos. This is just desmos.com. And then I think it's /scientific, but you can just go to desmos.com, math tools, click, choose the scientific calculator. So you're just going to go radical sign 121, and it will give you the answer right here. Okay. You don't even have to hit enter. You can if you want to start a new one. Okay. If you want to do like the 3rd root or a cubed root, you're going to go, nope. Sorry, that's how you do it in my calculator. All right. So you're just going to press that button with the N, and then it will give you space. It will start your cursor above in the index position, and you can say, oh, what's the 4th root of 6561, right? It's 9. What's the 3rd root of 27, right? Okay, so that was just that. Good. All right, so the square root of 121 we saw is 11 because our calculator told us. Right? The square root of 256, well, that's not on here either. Oh, but it's the 4th root of 4. Or it's the 4th power of 4. So the square root of 256 is 16. There's a negative in front of it. So you can put the negative into your calculator and say that it's negative 16, or you can like break them apart and say, well, I know to just carry the negative, right? The negative just remains a part of it and I bring it over once I figured it out. 256 is 16 because 16 times 16 is 256. You could even say this becomes negative square root of 16 times 16. There's a 2 in the index, so I need to find a pair of 2, and that pair is 16, and so I bring the 16 out, carry the negative sign. But as soon as you find a pair, you pull it out, okay? The square root of 121 is 11 because the square root of 121 is the square root of 11 times 11. 11 is a pair of the same number as factors, right? 11 and 11 are both factors of 121, and so we pulled out those two factors because they are the same. It's a pair of the same number times itself. All right, what about if it's in fraction form? Do not worry. Remember those exponent rules where we could say 1 over 100 to the power of 2 is just 1 to the power of 2 divided by 100 to the power of 2? Well, you can do the same with a radical. So the square root of 1 over 100 is the same as the square root of 1 over the square root of 100. The square root of 1 is just 1 because 1 times 1 is 1. The square root of 100 is the square root of 10 times 10, which is 1/10. Okay? If that helps. Number 10 is asking us to find the square root of 324 divided by 121. Let's just hope 324 is a perfect square, and it is. It's 18, right? So we're going to say the square root of 324 divided by 121 is the same as the square root of 324 divided by the square root of 121. The square root of 324 we learned was 18. And the square root of 121 is 11. Good. The square root of 0.81 0.9. The square root of 0.04, if 81 behind the decimal became 9, what is 4 going to become? 2. Good. All right, now it's asking us something different. It's asking us to find the cube root. If you use the square root to find the cube root, you will not get the right answer, okay? We know if we look at the table we made, 125 is 5 cubed. So our answer is the cubed root of 125 is 5. The square root of 125 is 11.18. What do we need to do? We need to find a way to use the cubed root in your calculator, okay? If you don't know, you can just type in the name of your calculator and the word cubed root, and somebody will have a video. For me, it's math. If I want to go bigger than cubed root, I have to type in the number before 10, and then go down to that number 5, right? And then again in Desmos, you're using this button or this button, okay? Look at now, I'm all confused. No. All right. So the cube root of 125 is 5 because 125 becomes 5 times 5 times 5. And those are 3. A group of 3. A group of 3 comes out as itself. 5 times 5 times 5 is 125. So the cubed root of 125 is 5. Here is 512 with a negative sign in front of it. Remember, that just means put the negative sign carry the negative sign over to the other side of the equal sign. The square root of 512, or sorry, that was not on purpose. The cubed root of 512 is 8. So the negative cubed root of 512 is negative 8. The cubed root of negative 125, you can just put it in your calculator, is negative 5 times negative 5 times negative 5, which is negative 5. Good. The cubed root of 1/8, same thing. We're going to say the cubed root of 1 over the cubed root of 8, and you can just put that in your calculator. The cubed root of 1 is the cubed root of 1 times 1 times 1, so that's a group of 3, so you can just say it's 1. And then 8, what number times itself 3 times can equal 8? It's 2. 2 times 2 is 4, and then times 2 is 8. So the cubed root of 1/8 is 1/2. You can also do it in your calculator. The cubed root of 1/8 is 0.5. 0.5 is 1/2. Let's see what that would look like in Desmos. So we have the cubed root of 1/2. Sorry, 1/8. If you want it to be a fraction, press that button. If you want it to be decimal, press it again. Do you want it in fraction form or converted to decimal form? Yep. Okay, find the root. Negative 4th root of 16. Oops, I have to put in the 4 first. 4 math 16 is 2. There was a negative sign in front of it, so you can say negative 4. No. Negative 4. This is not even useful to you because you don't have this calculator. 16. Huh. That's not what I wanted. Negative 2. That's not easy. In Desmos, it will be easier. So we've got negative 4 root of 16 is negative 2. You can also just say the 4th root of 16 is positive 2, and then there's a negative in front of it, so I'm going to call it negative 2. That is fine as well. Good. So that's negative 2. The 4th root of 256 is 4. The 4th root of negative 16. If we put this into our calculator, we're going to get an error. Why? Because it's an even index with a negative radicand. Non-real answer. All right, so it's okay if the negative is outside, we just carry the negative. If it's inside, it's a non-real answer. There is an answer. We'll talk about it with complex numbers, but for this lesson, it's no solution. Okay. All right, the 5th root of 32 is 2 because 32 is 2 times itself 5 times. We're looking for a number multiplied, or a term multiplied by itself the same number of times as the radicand. The radicand should be the same as the number of factors, right? So because it's a group of 5 2s and the index is 5, the 5th root of 32 is 2. The 5th root of 243 is 3. I'm going to carry the negative. I'm not even going to put it in my calculator, right? My calculator is a little bit old. It's hard to put it in there. Okay, without using the calculator, what is the approximate answer for the square root of 22? This we would use our table for, right? Square root of 22. It's not 2, it's not 3, it's not 4, it's almost 5, right? 22. If we had the square root of 25, it would just be 5, right? And if I had the square root of 16 on this side, it would be 4. 22 is between 16 and 25. So 22 is going to be between 4 and 5 is our approximate answer for 22, right? The square root of 8 is between the number 4 and the number 9. So square root of 8 is between the square root of 4 is 2. The square root of 9 is 3. So we're going to say that the square root of 8 is between 2 and 3. Those were square roots. This next one's a cubed root. So the cubed root of 100, we're looking at the cubed column. It's not 1, it's not 2, it's not 3, it's not 4, but at 5 we pass it. So again, it's between 4 and 5 because 100 is between 64 and 125. So the cubed root of 100 is between 4 and 5 because the cubed root of 64 is 4 and the cubed root of 125 is 5 and 100 is between 64 and 125. So it's not a perfect answer. It's not a perfect square. It's not a perfect cube. Good. Okay. Approximate the root to 3 decimal places just means put it in your calculator. Square root of 53 is 7.28. Oh, 280, right? We're rounding 7.280. The square root of 97. So just make sure you know how to round to 3 decimal places. 9.848, right? 9.84, but look at that. 8, and then the number behind the 8 is also an 8. If this number is 5, 6, 7, 8, or 9, you say 9.849. You round up, okay? The square root of 211, 14.5258. Again, that's an 8. That's a 5, 6, 7, or 8. We're going to say it's 14.526 because this is closer to 50. The number 58 is closer to 60 than it is to 50. Okay. So we're going to say 14.526. If I had to round 58, I'm going to round 58 to 60 before I'm going to round it to 50. Same here. If I have 8, 4, am I going to round 88 to 80 or 90? I'm going to round it to 90. Good. The cubed root of 489 is 7.88, right? Oh, sorry, 3 decimal places. 7.878 because 83 is closer to 80 than 90. 7.878. Good. How's this done in your calculator? I think we've gone over that and how to do it in decimals, right? So how would you simplify the square root of negative 11 squared? Well, and it doesn't matter which one you do, you either take the square root of negative 11 and then square that, or you take negative 11 squared, or you take negative 11, multiply it by negative 11, and then take the square root. So I'm going to expand negative 11 squared. It just means it's negative 11 times negative 11, right? Negative 11 times negative 11 is also just what they said. It was negative 11 squared. So it's negative 121. Oh, sorry. It's not negative 121, it's positive 121. I'm supposed to be teaching math here. Let's wake up. Good. So I expanded negative 11 squared to become 121 because a negative times a negative is a positive. I just put it in my calculator wrong. Second thing I put in my calculator wrong. Good. And then we just say, what is the square root of 121? It's 11. Good. So because we multiplied it by itself, it became positive, right? And then we took the square root of the positive number and we got 11. Here we have the cubed root of negative 5 cubed. So that's negative 5 times negative 5 times negative 5. Negative 5 times negative 5 is positive 25 times negative 5. Negative 5 times positive 25 is negative 125. Ooh, sorry. I have been ignoring that this is not a square root, this is a cubed root. So now we're taking the cubed root of a negative 125, which is negative 5. Okay, so notice that if you have the same sign, or sorry, the same index and exponent, you can cancel them. However, if it's an odd, you keep the negative. If it's an even, it's no longer negative. It gets rid of the negative because a negative times a negative, an even number of times becomes a positive, right? So negative 11 times negative 11 becomes a positive, and then you take the square root. But basically I would do it the long way just to make sure, okay? Take negative 5 correctly in your calculator, not like me. Negative 5 to the third, and then what is the cubed root of that? Okay, that will not lead you wrong. It's maybe one extra step, but it's going to give you the right answer, okay? So now there are two general approaches for simplifying variables inside of radicals, and the key is the index of the radical. What I've been showing you is the grouping method. So how many groups of the size of the index, right? How many groups of 3 can I take out? Okay, so find out how many groups of the size equaling the index there are of the variable. That number of groups is equal to the exponent on the variable on the outside, and any leftover variables stay inside the radical. Or long division method, divide the exponent of the variable by the index. The whole number part is the exponent, the outside, the remainder is the exponent left on the inside. Okay, let me explain that. X to the 8th. So remember, this is an understood 2, right? So x to the 8th, the grouping method is going to give me x to the 8 is 8 x's. Correct? And then I group them according to the index. Right now our index is 2, so I'm going to group them by 2s. Here's a group of 2, here's a group of 2, here's a group of 2, and here's a group of 2. Okay, each of those groups accounts for 1 on the outside. So I take a group and I move it out as itself. So this is still the grouping method. The square root of x to the 8th now becomes, right? This x comes out. So here's the radical with all those x's, but the x's come out. So this group represents 1x outside because x times x, remember, sidetracked, sorry. Right, once you have a group, the size of your index, it comes out. So those 2 came out, those 2 came out, those 2 came out, those 2 came out. There's nothing left under because that was an even divided by the number 2, right? Then there was an even number of x's put into groups of 2, so we just have 4 x's and nothing under the radical. And so we can say x times x times x times x? Nothing under the radical, or just x to the fourth? Okay, so that's called the grouping method. You just group them. This is 1, 1, 1, 1. So 4 come out, right? That one comes out, that one comes out, that one comes out, and that one comes out because we made groups of 2. 8 gives you 4 groups of 2, so you have x to the 4th. X times x times x times x is x to the 4th. Good. And then you have the long division method, which would be the square root of x to the 8th is, and then you're going to take 8. How do I want to do this? I want to take 8 divided by 2 is 4, remainder 0. So x to the power of 8 divided by 2 is 4. And there's no remainder. The remainder would be under here. But there isn't any. I'll show you again. The cubed root of x to the 3rd, grouping method. Good. There's 3, and the index is 3, so that's just one group. Those 3 come out, and we just have x. The other method was division. So cubed root of x cubed is x to the power of 3 divided by 3, which is 1. So it's just x to the 1st. Same thing, right? It's just going to be x because it's 6 divided by 6 is 1, or a group of 6. Taken out is just x. So that would be x. 6 divided by 6 is x to the power of 1. Okay, the square root of x. Now it'll be a little bit easier to see. Grouping method, there's nothing to group, right? The square root of x is just x. So you cannot take anything out. There's no group of 2. So you just say it's x. Here, our index is 2 and our exponent is 1, even though it didn't give us either, right? It was understood that that was a 2. It's understood that that was a 1. So now we have x to the power of 1. Sorry, 2 divided by, no, sorry, I got nervous. Ignore me. Okay, the square root of x equals x. Take that first number divided by the index. Take your exponent divided by the index. Take your exponent divided by the index. Can't tell here because they're both the same. Take the exponent divided by the index. Take your exponent divided by the index. It doesn't give you any whole numbers, and it gives you a remainder of 1. And the remainder is what stays under the radical sign. Okay, so the square root of x to the 5th. Grouping method is going to say there's 5 of them. Right? And then we're going to group. So this is, and we're grouping by 2s because that's what the index is. So these 2 are a group and these 2 are a group, and there's 1 left over. So what we have is x times x taken out, and then 1x left in, which is just x squared x. That's grouping method. And then the long division method would be, that's an understood 2. We know that's a 5. Is going to be x. Take your exponent and divide it by your index. Take the exponent divided by your index. And what you get is 5 divided by 2 is 2, remainder 1. So that's going to be x squared outside and then 1x still inside. The answer is how many x's are outside. The remainder is how many x's remain underneath. Okay. 5 divided by 2 is 2 remainder 1. So that's x squared, and the remainder 1 stays under there. X to the 7th, very similar, right? Grouping method is going to give me 7. X to the 7th equals 7. So I'm going to group them. That's an understood 2. 1, 2, 3 groups of 2. So that's now x times x times x. Square root x. So that's x to the 3rd square root x. Good. Division method. That's a 2 and that's a 7. So we're going to say it's x to the power of 7 divided by 2 is 3, right? Because 6 divided by 2 is 3. Remainder 1. So it's going to be x to the power of 3 with 1x still here. My remainder's underneath there. The 3 x's are outside. And that's the same answer I get with the grouping method. 81x to the 10th. So you can take the number part separately from the variable part. So the square root of 81 is going to be 9 because 9 times 9 is 81, right? So the square root of 81 is just 9. And then you have the square root of x to the 10th. Right, so here's the grouping method. Grouping method says that this is an understood 2, so I need groups of 2x. I have 5 groups of 2x's, so that becomes x to the 5th. So my answer to the square root of 81x to the 10th is 9x to the 5th. If I wanted to do it by the division method, it was 9 square root x to the 10th. Remember, that's a 2. So that x to the 10th divided by 2, 10 divided by 2 is 5. So it's just x to the 5th. So it's 9x to the 5th. So sometimes division is easier, sometimes grouping is easier. Whatever you prefer. All right, guys. The square root of 121x squared. The square root of 121. So they're totally separate parts. 121 is 11. 121 becomes 11, and then x squared. The square root of x squared. X times x, and then we're grouping them. So it's just 11x, right? Or 2 divided by 2 is just x. The square root of x squared is x. For this next one, we have 2 variables. We have an x squared and a y, and then we have the 63. So see if you can take the square root of 63. We cannot. Okay. When you get a number that you cannot, that is not a perfect square, what should we do? We should turn it into a factor tree. Okay. Just like if it had given us 64, right? We could have said it's 8 times 8. That's a factor tree of 64, or a factor pair of 64. Good. 63. Ooh. All right. 63, and we have the square root, right? Square root column. So our square roots are, I'm gonna make a little list of our square roots, all right? Our perfect squares. I'm making a list of perfect squares, definitely not square roots. Perfect squares are 2 squared is 4, 3 squared is 9. All right, for now, I'm just gonna leave it at 64 because we only need it to 63. So what I'm gonna do, instead of making like a big long factor tree and probably confusing you inadvertently in the process, I'm gonna take 63 And I'm going to see if I can divide it by 4, by 9, by 16, by 25, by 36, or by 49. Okay. So 63 divided by, and you can start at the bottom or the top, whatever you want. 49. No. 63 divided by 36. No. 63 divided by 25. No. 63 divided by 16. No. 63 divided by 9. Yay. So, excuse me, 63. 64 would have been 8 times 8. 63, you want one of your factor pairs to be a perfect square. And our perfect square was 9. We said it was 9 times 7, right? Okay, take that 63 and say it's 9 times 7 times x squared is x times y, right? So I kind of like broke it up. Why did we care about 9? Because 9 is 3 squared. So you can even break it up further into 3 times 3 times 7 times x times y. Now we know that that's a 2. So now we're looking for pairs. Okay. Pairs of 2 of the same number, like this 3 and like this x. Okay. Now I'm going to take out 3x. Everything else just stays under there. It was a 7. Oh, it was just a 7 and a y. Good. Okay. 7, I cannot factor it any further. I can't divide it by 4. I can't divide it by 9, obviously. It's smaller than 9. Good. 243. Let's make sure. 243. It is not a perfect square, so I might need to write a few more out just to be sure. 9 squared is 81. 10 squared is 100. I think 11 is 121. It's probably good. Yeah. All right. So 243, can we divide it by 121? No, very close though. 243 divided by 100, no. 243 divided by 81. I start at the top just in case, just so that I don't get a big number or get a really small number, and then I have to like redo it over because it was too small a number. So 9, right? Because if I had done 243 divided by 9, it would have been 27, and then I would have had to do a lot more work. Whereas 81 and 3, 81 is a really big number that switches to 9, but this would have been 3 times 3 times 3 times 3 times 3. Anyway, I start at the top because it's actually less work, even though it might take longer. It's less of like my brain working. All right. What we decided was it was 243 divided by 81 is 3. That means 81 times 3, fact families, right? 81 times 3 is 243. So 243 now becomes 81 times 3. Why do I care? Because 81 is 9 times 9, so 81 will come out. Just like 9 was 3 times 3, so 3 came out. 81 is 9 times 9, so 81 will come out as 9. Okay? Times k to the 7th. So you can either say 7 divided by 2, the long division way, or you can write out 7k's and group them. One, two, three, four, five, six, 7. Good. And then you have 8 Q's. Make it a different color. 1, 2, 3, 4, 5, 6, 7, 8. And maybe it's easy for you to see that, well, 8 divided by 2 is 4, so it's just going to be Q to the 4th taken out. But I'm not sure about 7 because 7 is not an even number. So you can do like half and half, whatever method you like. Again, 81 becomes 9 times 9. 9 times 9 times 3. The 9 times 9 comes out. So now I have 9 square root 3. Let's look at the k's. We need pairs of k's, okay? 1, 2, 3. And then 1 is left over. Good. And then the q's, 1, 2, 3, 4. And there's no q's left over. Okay. And I know I kind of spread that out, and you could have put, if I had left room, I could have put the k to the third here and put the k here. So this is the same as 9k to the third, q to the fourth with a 3k underneath. It's exactly the same. I just wrote it differently. That gets anything outside the radical gets multiplied by anything outside the radical. 9 times k to the third times q to the fourth. And then anything under the radical gets multiplied by anything under the radical. 3 times k is 3k. Okay. Cube root of 729. Ooh, look it. 729 is on our table, so it's just 9. Hooray. So the cube root of 729 becomes 9. So we're just immediately going to rewrite that. Cube root of x to the 16th. Do you want to try it the long division way? So if you don't want to try it the long division way, to write out 16 x's and then group them by 3's. But the long division way is going to say x to the power of 16 divided by 3 is, right? And if you put it in your calculator, 16 divided by 3 is 5 point something, right? So what we know is it's going to be 5 with a remainder. Why? Why, and how do we find out what the remainder is? Just do some long division. So 16 divided by 3, right? How many times does 3 go into 16? It said 5. Why would it say that? Because 3 times 5 is 15. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. But 3 times 6 is 18, and we can't go past 16, right? So we have to say it's 5. 3 times 5 is 15. So we're going to subtract 15. 16 minus 15 is 1. So it's 5 remainder 1. Good. So that means we have x to the 5th square root x, because the number we got on the calculator, the first term, that's how many come out. And then the remainder is how many stay under. It's just remainder 1, so 1 stays under. You're also welcome to write out 16 x's. Right? And then group them. How many groups do I get and what's left over? 1, 2, 3. Oh, I put them in groups of 4. Ignore that. Put them in groups of 3. 1, 2. And again, you see you have 5 groups, so the x to the 5th comes out, and then you have 1 left over, so that 1 just stays. And remember, we had that 9. So 9 x to the 5th, cube root of x. I often forget to add the cube root, even though I'm treating it like a cube root, I forget to add it at the end, so don't do that either. All right, the cube root of 512 is 8. The cube root of x to the 4th So if we wanted to do it by the grouping method, 512 was 8 times 8 times 8. So the 8 came out. 3 x's come out and 3 y's come out. So that's 8x. Sorry. 8xy. I didn't leave room for that y. And then there's a remaining x, a remaining y, and a remaining y, but you need to put that into y squared. So it's 8xy square root, cubed root, xy squared. Because y times y becomes y squared. Good. All right, last one, and then we'll do 3 distance formula examples, and we will be done. So the cube root of negative 125 is -5 times -5 times -5, right? So those come out as -5. And then x to the 36 divided by 3, right? We're going to do the division formula because I don't want to write out 36 x's. So 36 divided by 3 is 12. And why did we say that it's 36 divided by 3? Because we said the exponent divided by the index. So it's -5 x to the 12th y. -5 x to the 12th. And then y stays under there. I just couldn't write the 3 next to the 12. Blah, 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 blah. Why does the y stay under there? Because only groups of 3 y's can come out, right? And that one's definitely not going to come out. It's just a 1. It was faster to take the exponent and divide it by the index than to group them. -125, I can look at my table, or I can just put it in my calculator. It's -5. Good. All right, the distance formula says that the distance between 2 points, 0.1 and 0.2, is the x value of 0.2 minus the x value of 0.1 squared plus the y value of 0.2 minus the y value of 0.1 squared, okay? Exact answer means they leave the answer as a simplified square root. Good. All right, so here they have the point 2, -5, and -6, 11. So you just need to decide which one's x1, which one's y1, which one's x2, which one's y2. This looks like x1, y1, x2, y2, right? So x1 is 2, x2 is -6, y1 is -5, y2 is -11. Good. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Why do I always run out of space? Good. -11 minus -5. There's a minus there, and they were both negatives. Okay. Distance equals, all right, -6 minus 2 is a -8 squared. Keep the parentheses because you need to put parentheses around the -8. That whole thing is squared. Okay. Plus -11 minus 5 is -16 squared. Nope, it isn't, because minus and negative becomes plus. -11 plus 5, -6. So we have -8 squared plus -6 squared. -8 times -8, right? If you just said -8 squared, it's going to give you a different answer. So make sure you use those parentheses. -8 squared. 64 plus -6 squared is 36. 64 and 36. 100. And then try to simplify it. All right, we know that 100 is 10 times 10, which is 10. Good. All right, 5, 1, and -6, -2. So it's x2 minus x1. Nope, that's y. x2 minus x1, -6 minus 5 squared plus y2, y1, -2 minus 1 squared. Good. -6 minus 5 is -11 squared plus -2 minus 3 is -3 squared. So that's 121 plus 9. It's 130. Good. Can you take the perfect square of 130? No. So what you want to do again is look at that list of perfect squares and say 130 and start dividing them by probably not 100, right? 130 divided by 81. 130 divided by 64. 130 divided by 49. 130 divided by 36. 130 divided by 25. No. 130 divided by 16. No. 130 divided by 9. 130 divided by 4. No, we cannot simplify it. Okay. That's the simplest form. All right, then we have -4, 1, and 1, -17. I think it made more sense to label them first than to just go. So x1 is -4, x2 was 1, y1 is 1, y2 is -7. Good. And then the distance formula is the square root of x squared minus, or sorry, x1 minus y1, x2 minus x1. The distance formula is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. x2 minus x1 quantity squared plus y2 minus y1 quantity squared. We good? We good. All right. 1 minus -4 is 5 squared. You don't need parentheses if it's positive, but you can keep it. Plus -7 minus 1 is -8 squared. You do need parentheses. So that's the square root of 25 plus -8 squared is 64. 25 and 64. 89. 89. And then just to make sure we can't simplify 89, we're going to go down the list and say 89 divided by, right? 89 divided by 49? No. 89 divided by 36? No. 89 divided by 25? 89 divided by 16? 89 divided by 9? No. 89 divided by 4? No. Right? So we just leave it as that. That is the exact answer. If they want the decimal, then you just put in the square root of 89. And they will tell you what to round it to, right? So this would round it to three decimals would be 9.434 because 39 is closer to 40 than 30. All right, guys, that is it. Thank you so much for watching, and I hope you have a wonderful day.